All right, greetings, fellow grade 10s. It's Mr. Shachai again. Look, we are back with some another amazing content. So what you're going to be basically looking at today, we are looking at our stoichiometric calculations, and we are going to be trying and seeing in terms of how can we then solve these particular questions, right? Now, let's start here. Now, the first question, rather they are saying now, the reaction between sodium and water is represented by the balanced chemical equation here, right? So you are given our balanced chemical equation here, right? And now, the first thing they say during the reaction, now you're having 10 grams of sodium that reacts with 2 decimeter cubed of mole to now produce hydrogen gas at STP. Now, the first thing, 9.1, they say now write down the value of temperature and pressure at STP. You know, so that we get this one, let's start here. Remember that now the first thing, STP, it represents your standard. It's represent your standard temperature and pressure, right? Temperature and pressure, right? So it basically represents that. So now, therefore, the standard temperature, firstly, they want us to determine what is the value of the standard temperature. Now, the standard temperature, the value of it is given by what? Let's get another nicer color there. It is given by 0 degrees Celsius or your 273 kelvins, right? So this is the representation of your standard temperature. Whereas now your pressure, it is represented by 101.3 kPa, which is your kilopascals, right? And your P, it is a capital letter P. So let's fix that. Your P, it is your capital letter P. So this is going to be 101.3 kilopascals. So these are the standard, this is the standard temperature here, and this is the standard pressure, isn't it? So now hopefully you get that one. Now let's look at now our 9.2. Now in 9.2, firstly, the first question is now they want you to calculate the mass in grams of hydrogen produced. They want us to calculate the mass in grams of hydrogen produced. Now, what is it that we have from here? Now, they say during this reaction, you have 10 grams of sodium, which reacts with your 2 decimeter cubed of your what? Of your hydrogen gas. And they want us to calculate now what is going to be the mass of hydrogen gas that is used in this. Now we are going to start here. We are going to start with something where we are given at least maximum information here. Now, if you can look at this particular reaction, the only thing that can at least help us to start by finding the mole, it is our what? Our sodium. Because look, from your sodium, you have the M here, and you can use the your molar mass of your sodium to calculate the mole. So that's where we are going to start. We are going to say, look, now if you can start by calculating what is the mole of your sodium, this is going to be given by the mass over your molar mass. And we are saying now the mass of your sodium is given by 10 divided by what is the molar mass. Now the molar mass of your thinking, I think this is going to be your 23, your sodium, and the number of moles that you're going to have, this is going to be 0.43 mole, right? This is going to be 0.43 mole. That is going to be now the mole that you are going to find for your sodium. And now whenever you are given a balanced reaction, any or one or any element or compound, if you have the mole, let's say now, because you are having the mole of your sodium, you can use the mole of your sodium and these ratios and all these ratios to find out what is going to be your mole of anything in this particular reaction, right? So which means in this case now we are going to compare the mole of your sodium with the one that you are looking for. Remember here we are looking for your hydrogen gas, which is this one. Right, we are going to start here. Now you are having your Na, which is to your hydrogen gas. Now, what is going to be their ratio? Look, the ratio that we are considering, we are looking at this number just before that particular atom, right? So here, what is it, the number that you're having here? It's same as 2. And now if you check your hydrogen, you are having what? You are having 1 here. So which means the ratio of your sodium relatively to your hydrogen gas is 2:1. And what is it that now we are having here? And the mole that we are having for our sodium, it is given by what? It is given by 0, what? 0, 43 mole, right? So which means now the relative mole for hydrogen gas, therefore, because the ratio is now, if you are having 2 moles of this your sodium, you're going to have 1 mole of your hydrogen gas. Now, which means you're going to say this is going to be represented by what? This is going to be 0, 43. Now, divide by 2 to find out the mole of your hydrogen gas. And the mole of your hydrogen gas that you're going to find here, this is going to be same as, this is going to be, I think this is going to be 0, 22 mole. So which means your mole of your hydrogen gas now, it is going to be given by 0, 22. Isn't it so? Now that you have the mole of your hydrogen gas, now you can now continue, go ahead to calculate the mass. Remember that, look, mole, isn't it that mole, it is given by the molar mass, rather the mass over your molar mass. And now, because what you are looking for, you are looking for the mass, and your mass, in this case, your mass is going to be given by what? The mole multiplied by your molar mass. Isn't it so? And now let's see. So we are saying now your mass of your what? Your mass of your hydrogen gas, it is going to be given by its mole, and its mole, it is 0.22 multiplied by the molar mass. It's going to be same as 2. Remember, the mass, it is 1 and the subscript is 2. So this is going to be 2. Are we together? And therefore, when you multiply this, you'll realize that you are going to have what? You are going to have 0, 44 grams as your molar mass. Are we together? Now, this is going to be 0, 44 grams of your mass of your hydrogen gas, right? Yes. And then you are getting your full 5 marks. You put them in your bag. You continue. Now let's look at your 9.22 now. In this question 9.22, let's look in terms of what they require us to do. Now they say, what is the volume in decimeter cubed of your hydrogen gas now produced at STP? I mean, now the only formula, I repeat, the only formula for us to calculate the volume at STP, it is what? Remember the formula that you're having at STP, it is going to be N, which is given by what? Which is volume over your VM. This is the only formula at STP. At STP, right? So now, and then what is it that we are going to do? Now we are going to say, now firstly, do we have the mole of this hydrogen gas? Yes, we have the mole because we've calculated it here, right? Remember, we've calculated the mole in here. This one, the one that is highlighted, we calculated the mole. So yes, we have the mole. And do we have also the VM here? Do we have the VM, which is the molar volume? Yes. Remember, your molar volume is always 22.4 decimeter cube, right? So which means we are having this and you're having the mole. So therefore, we can calculate for the volume. So the volume of your volume of your hydrogen gas, it is going to be given by the mole, and the mole of your hydrogen gas, it was 0.22 multiplied by the molar volume, which is 22.4, right? And then this one is going to give us what? When you multiply these two things, I think you are going to get, let's see, this is 4.93 decimeter what? Decimeter cubes, because every time whenever you're calculating volume, it is always measured, or the units, it is decimeter cube. So please ensure that you do not forget these units, right? Then you've calculated now you've calculated the volume at STP. Now then let's see, and let's try and see what our 9.23 9.2.3 require us to do. Now they want us now here to calculate the mass in grams of your NaOH, right? Which is your sodium hydroxide, if I'm not mistaken. Yes, it is indeed your sodium hydroxide. Now let's see. So now for us to calculate our sodium hydroxide, we are going to go back to our drawing, or rather, our table, or rather our balanced reaction, right? We are going back to our balanced reaction and see now, do we have anything for your sodium hydroxide? Do we have anything for sodium hydroxide? No, we have nothing. But since this is a balanced reaction, so we can use now this balanced reaction to calculate what is the mole, because every time your balanced reaction can at least give you the mole of either your reactant or your product that is found in that reaction. So we are going to use any mole that we found within this reaction to calculate the mole of our to find out what is the mole of our sodium hydroxide. Now let's use the mole of your sodium. Look, we are going to say now, look, your Na, your sodium is to what? Your sodium is to your sodium hydroxide, right? And now what is their ratio? Look, their ratio is 2:2, right? Remember, the ratio is this numbers, right? These numbers here, right? Now their ratio, it's 2:2. So which means now, what is the mole of your sodium? The mole of your sodium that we found then, it was what? It was 0.43. Remember, when we started by calculating, we found out that the mole of our sodium, it was 0.43. So which means this is 0.43 is 2. Now, if the ratio is 2:2, it's same as 1:1, right? So which means the mole also of your sodium hydroxide is going to be 0.43, right? This is going to be the mole of your sodium hydroxide. And now, after now you found out what is your mole of your sodium hydroxide, now we are going to say, they want you to calculate what? The mass. So now, and what is the formula that we use to calculate the mass? Remember that mole, it is given by what? It is given by mass over your molar mass. And in our case, look, we already have the mole, which is the one that we've just used the ratio to find out. And we can be in a position to calculate the molar mass. So therefore, we can get what is the mass of it, right? So which means now, if we are drawing here, look, now our mass, it is going to be given by what? Our mass of our sodium hydroxide. It is going to be given by firstly the mole that we found out. It is 0.43 multiplied by what is going to be the molar mass. So the molar mass that you're going to find, for those who have forgotten, remember that your molar mass from your periodic table of your sodium, it's 23, plus the one of your oxygen is 16, plus the one of your hydrogen is 1, right? So therefore, which means your mass in here, or the mass that you are going to find, it's going to be, I think this is 17.2 grams. So this is going to be 17.2 grams of your what? Of your sodium hydroxide. This is the grams of your sodium hydroxide that is produced altogether. So this is the gram of your sodium hydroxide that is going to be produced in here. Now let's look at now our last question and see in terms of what our 9.24 require us to do. Now in question 9.24, what they want us to do, basically they want us to calculate now what is therefore going to be the concentration of these particular sodium hydroxide in here. Now, and for us to do that, now we are going to back to our statement. Now they say now the sodium, they say during this reaction, sodium react with 2 mole per decimeter cube 2 mole per decimeter cubed or decimeter cubed of water to produce hydrogen gas at STP. So which means now, for us firstly to calculate the concentration, we are then going to say what is going to be the volume in which we are having this. Now, which means our volume of our the volume of our product is what? it is 2 moles per decimeter cube. So, and our concentration, remember the concentration is given by what? Concentration is always given by the number of moles over the volume. Now, so which means our concentration of our sodium, remember we are looking for the concentration of our sodium hydroxide, right? So the concentration of our sodium hydroxide is going to be the mole first. And what is the mole that you're given? The mole of your sodium hydroxide we found there using the ratio, which was 0.43, right? And then this is going to be 0.43 divided by the volume. Remember, the volume is going to be the same here, which is the 2 mole per decimeter cube, which is going to be the 2. So therefore, which means your concentration of your sodium hydroxide, it is going to be given by what? It is going to be given by 0.22 molar per decimeter cubed. Mole per decimeter cube, right? So this is going to be now you finding the concentration. So basically now this is how we are going to solve all these questions of ours, right? So now thank you very much.